Good afternoon, everybody. Today we are having webinar on CHNSO Analyser. And before starting this talk, I would like to invite Professor Suparna Mukherjee, head of the department of our SAFE department, and she will give you the brief introduction about the SAFE facilities, instruments, and its activities. Professor Suparna Mukherjee.
Thank you, Dr. Mayuri. I welcome you all to this webinar, and with that, I would like to first introduce SAIF, that is the Sophisticated Analytical Instrumentation Facility at IIT Bombay, which is an open access facility for R&D work. And so this facility, actually this Sophisticated Analytical Instrumentation Facility was set up way back in 1976 in IIT Bombay with DST support. And subsequently, we had the Center for Research in Nanotechnology and Science that was set up in 2005-06. And after that, the two were merged. So now we have this jointly operating SAIF and CRNTS at IIT Bombay. In SAIF, we have 15 major instrumentation facilities. And in CRNTS, there are 6 major equipment. And we actually have a large number of PhD students, about 90 students are there currently. And we work with faculty all over the institute. So we have about more than 100 associated faculty members in CRNTS. And we receive samples from all over India. Currently, for example, in the last financial year, we had around 1749 users and more than 13,000 samples were analyzed in SAIF. So I would like to give you an idea of the type of facilities we have. So CHNSO Analyser, which is newly installed. In fact, we did have one earlier, but this facility has been newly installed again after the writing off of the old one. And we also have various chromatography facility, the high resolution GCMS. We also have a high resolution LCMS, both QTOF and Orbitrap, and ICP-MS facility and TOF SIMS. Apart from that, we have various electron microscopy facilities, then the ESR and also NMR. And then small angle X-ray scattering was set up a few years back. And there is also a dual beam FIB facility. In addition, in CRNTS and from the Institute Central Facility side, we have 6 other facilities also installed here. This is the ICP AES, Laser Raman, then environmental scanning electron microscopy, and also the FECTEM 200 and 2-dimensional GCMS and UV spec with integrating sphere assembly. So all the details of our facility are available in our web page, and facility usage can be booked through the web page. So I invite you to take a look at saif.iitb.ac.in web page. So this is showing the samples analyzed by us in 2021-22. As you can see, there are samples received largely from Maharashtra, but apart from that, we do receive samples from all over India. So we have been serving the country at large, and our staff work in members contribute to running the samples and operating the center smoothly. And apart from that, we also have various visitors visiting our center from time to time. And these are just some glimpses of such visits, although we had to limit the visits during the COVID pandemic. And we hold various webinars from time to time. And these are also available in the YouTube channel of SAIF IIT Bombay. You may take a look at that. And so we also have announcements about various activities of SAIF in our LinkedIn page. So I invite you to take a look at our LinkedIn page. And today now we will be having the webinar on CHNSO Elemental Analyzer and its applications. So I request Dr. Mayuri now to take over. Thank you. Thank you.
Yeah, thank you, ma'am, for introducing about the sub facility. So it gives me a great pleasure to welcome Mr. Chandrakant Pawar. Mr. Chandrakant Pawar has done his MSc in chemistry from Mumbai University in 2000. He has more than 20 years of experience in 2000. In 2013, he had joined Thermo Fisher Scientific. He is the application manager of trace elemental analysis. He handles CHNS, ICP-MS, ICP-OES, and AAS instrument with excellent method validation skills using the above mentioned technique. He is supporting the clients across India for training, applications, method development, various software maintenance training. He is also supporting the types of industrial fields, including some sample preparation techniques to fulfill the applications for pharma, food, environmental, petroleum, paint, polymer, public government, testing lab, etc. Now I take this opportunity of requesting Mr. Chandrakant Pawar to present his slides to everyone. And I would request all the participants, if you have any query regarding the CHNS element analyzer, so there is a question and answer tab. You can type in that and all the question and answers will be entering at the end of this webinar. Over to you, sir. Thank you.
Good afternoon, everyone. And thank you, Priyanka ma'am, for the brief introduction about me.
Yeah, thank
Yes. Now, first of all, thank you to IIT Mumbai and the SEP department to give us this opportunity for given the uh, online training to or online introduction of the CHNS to everyone. So I just share my screen. Please confirm that screen is visible to everyone. Anyone can confirm it.
Yes.
Yes, we can see.
Yes.
Yes, thank you. Thank you very much. So I am the Chandrakant Pawar and I am given the application support to all over India of the elemental analysis technique like CHNSO as well as ICP OES, ICP MS and AS also. In future also, if you have any trouble, not only CHNS but other elemental technique that ICP OES, MS or AS, anytime you can contact the SAFE department. They can contact me directly, and if I'm really happy to help of all of you. Now in elemental analyzer, are you see that in AS, ICP OES or ICP MS, we can analyze most of the element in that periodic table. But by the ICP MS or ICP OES, we can't analyze carbon, we can't analyze hydrogen, we can't analyze oxygen. Yes, we can analyze sulfur, no doubt, but we can't analyze nitrogen. For that element analysis, that CHNSO, it is useful. Actually, professor already showed that the list how many instruments they have, and in that list, if you see that CHN is very small instrument as compared to that other techniques that orbit wrap or LCMS or GCMS MS TOF. So CHNS is very small instrument, but yes, this is very interesting also to learn about that. So today we have to discuss about this. Thermo have that flash mart instrument is there. This is the instrument you can see. In flash mart analyzer, we can operates with the dynamic flash combustion technique, and with the help of the TCD detector, you can analyze the carbon, hydrogen, nitrogen, and sulfur by the combustion technique. And also you can analyze oxygen by the pyrolysis technique. Okay, for very less amount of sulfur analysis, it is also possible by that Fpd detector. So TCD detector is by default detector, and Fpd is the external detector. Yes, the range of that analysis, that carbon, hydrogen, nitrogen, and sulfur, you can analyze by 0.01%, means 100 ppm, to 100%, means 0.01% to 100%. You can analyze all that 4 elements as well as oxygen also, means 5 elements you can analyze. Yes, below of that, if you required for sulfur, then it is Fpd detector comes in picture. Now in flash mart, if you see that here, there are the two furnaces is there. There are the two furnaces. This is the left furnace and this is the right furnace. And that furnace we have to given the temperature 950. For CHNS, we have given the 950 temperatures, and for the oxygen, we have given the 1060 degrees Celsius. It's 1060 degrees centigrade. When we insert the sample, so what happened? We have to introduce the sample as well as we introduce the oxygen for the complete combustion. And for a moment, it comes the temperature up to the 1800 degree. In that 1800 degree centigrade, the sample is combusted completely and it is converted into the gases. So for that, just the moment it is flash will observe. So that is called the flash. And why we are called smart? Because with the through the software, means automation from CHNS to oxygen or oxygen to CHNS, we can easily convert through the software. And that for that purpose, we have to call that flash smart. Okay, so in organic element analysis principle, determination of carbon, hydrogen, nitrogen, sulfur, and oxygen in organic and inorganic materials. Remember, friends, we have to say that inorganic materials, so, but it is not truly completed because our furnace temperature is not much more than 950. Only that inorganic materials, if it is completely combusted at 950 degree, that we can analyze. Suppose you are given any oxides or anything and it is not completely combustion at 950, then it is not possible to analyze. In CHNS, there is very simple way. You can take the sample weight, put it in the tin container, then it is completely, you can wrap it properly, then combust it, then combustion is occur, after that reduction is occurring, and then after chromatography, we can detect by the TCD detector. Yes, micro and macro, both the type of analysis you can do it. Yes, but for the macro analysis, there is a different configuration, that is the NC soil configuration is there. And we have the CHNS configuration. Now, this is the schematic diagram. See, this is the left side reactor, that is we are using CHNS, and right side we are using for the oxygen. And these are the furnace. In that furnace, that reactor we are kept it here. Okay, now the important is Thermo Fisher has provided 15 years of warranty for that furnace. Means up to the 15 years we could not do anything for that furnace. Now, if you see that here, in that anybody can ask, it is possible we can analyze all that 5 elements simultaneously. So remember that when we have analyzed of CHNS, we have introduced the oxygen also for completely combustion. So there is a possibility we can't analyze oxygen with the CHNS. So CHNS you can analyze simultaneously, but oxygen we can do by the pyrolysis. Okay. So this is the reactor. It is a 950 degrees centigrade. Above is the copper oxide and below is the electrolytic copper. In copper oxide, it will be combustion and oxidation is occur, and electrolytic copper is doing the reduction. When it is a 950 degree temperature of that reactor, we take the sample weight in the tin container and we have to close it and we have introduced into that reactor. Now, when we introduce that reactor, similarly, we have introduced the oxygen also, only for 5 seconds. Then flash will occurring. and the temperature is reaches to 1800 degrees centigrade. In that 1800 degrees centigrade, whatever that carbon, nitrogen, hydrogen, and sulfur, it is converted into that species. If you see that now after that oxygen supply is switch off, oxygen supply only for the 5 seconds for the combustion purpose. Yes, but no doubt helium flow is continuously going on. Now here it is oxidation as takes place in copper oxide. After that means nitrogen is converted into nitrous oxide, carbon is converted into carbon dioxide, sulfur is converted into sulfur dioxide, trioxide. After that in electrolytic copper, reduction will occur. Means excess of oxygen, we have to reduce it. And then nitrogen is converted into nitrogen, carbon is converted into carbon dioxide, hydrogen is converted into H2O, and sulfur is converted into sulfur dioxide. Now this is passed through the GC column. Now here it is a TCD detector. So TCD detector is work as a Western bridge principle. So one flow is required for that analytical flow, and one is flow is for the reference flow. See, reference flow, there is nothing, will only helium gas will come. And here nitrogen, carbon dioxide, H2O, sulfur dioxide, that species will come. So on that basis, we can measure the our interested analyte or elements. So this typical chromatogram, you have to see that first is the nitrogen. We have called CHNS, but evaluation nitrogen first, then carbon, then hydrogen, and then sulfur. So this is our pre-packed GC column. Okay, again, here GC column is non-consumable. And important thing is TCD detector warranty also the 15 years. So Thermo has provided two major things. One is furnace warranty 15 years, and second one is TCD detector warranty is 15 years. Again, only you have to remember that whenever you on the TCD, you assure that helium flow should be on. If a helium flow is should not be on, and you can switch on the TCD detector, so maybe the chances it is damaged. So these are the things it is happen in CHNS analysis. Now here you can see that when we have converted to the oxygen, now what happened? We can change our autosampler from CHNS to oxygen. So this is manually we can do it. Again, if you see here in CHNS, right hand side, that is the analytical channel, and left hand side is a reference channel. But when you do the oxygen analysis, now that oxygen analysis line is the analytical channel, and other thing that CHNS line is the reference channel. So user have to want to switch your manually connections as well as auto samplers. Now you can see here analytical channel. Now oxygen it is going to the analytical channel, and CHNS channel it is going to the reference channel. Now here it is 1060 degrees centigrade reactor temperature. We have not introduced any oxygen here. It is going on pyrolysis, so nickel plated carbon and quartz tuning we are using. And here it is very important thing, we are using here silver container. See, in CHNS we are using tin container. Now it is happened 1060 degree centigrade. In 1060 degree centigrade, then combustion it is going on, and oxygen it is converted into a CO. And then nitrogen and CO both are it is going to the GC column, and we have to see the two peaks. First is nitrogen peak and one is the oxygen peak. If in your sample nitrogen is not there, so you can see only one peak, that is only oxygen. Now, if you see here, we want to change over here manually, each and everything do the manually. But Thermo has introduced one valve, that is a multi-valve controller. With the help of the multi-valve controller, user could not required to change over manually. Through the software, you can automatically switch over. So that's why it is called a flash smart. Smartly we can change it. If you see here for CHNS analysis, we have to set that left channel means CHNS channel, and polarity of that CHNS is positive. Right hand side channel we have given the negative. Only we have to switch over and just click on send. So automatically it is switch over. Nothing any requirement to manually change over. Now, in simultaneous analysis, you can occur. Simultaneously means in one side CHNS it is going on. After complete CHNS, you can do the oxygen analysis. Again, switches left channel to right channel or right channel to left channel, vice versa. You can save your gases helium flow through that MVC valve. You can use other gases also, nitrogen for standby condition or anything, argon gas also. So how it is work MVC? See, here it is helium gas is there and here it is a CHNS. So first we can think that we can want to analyze CHNS 30 sample. So CHNS it will be going on. Now I want to analyze in that same sample oxygen also. So again I take 30 samples weight, okay, and I will keep in that auto sampler, right hand side auto sampler. So automatically MVC change the channel and we can start that analysis. After that oxygen analysis, again I want to that standby mode. Through the MVC, we can put that the standby mode and see that that time we can reduce the gases from 140 to only 10 ml per minute. And same time you can decrease the furnace temperature also. Then again, I want to suppose after 1 hour or 2 hours, I want to analyze again CHNS. Then again, we can use the warm up call like that, and we can start the analysis of CHNS. So this will be happen through that MVC module. Now, for the CHNS analysis, who is the actual they analyze that? So most of the universities for that purpose they are using identification of the samples. Pharma customers mostly they for the R&D purpose they're for whatever they have to R&D that equally similarly pattern of substance or material it is made or not. Then sometimes cosmetic divisions also in food industries also, again contract lab, even most of the times uh, environmental company or chemical company it is used. So characterization of organic and organometallic compound mainly it is using. Similarly fine chemicals also and research institute. The important thing is here it is very easy to use. Again sample preparation is not required. You can directly take the samples from that your as a sample. Only remember that the homogenization is very important. Sample should be homogenized is required. Otherwise, because we have taken only 2 to 3 milligram of sample for the analysis, so homogeneity is very important. If the sample is not homogenized, then you could not get the repeatable results. And different modules is there. CHNSO is there, the basic model, but if customer is required only CHNS also possible, CHN. Again, CHN and CHNS, only NC soil, only protein analyzer is also there. So FlashMart is high automatization and high productivity, accurate and precise sample. Yes, no doubt for pharma customer, 21 CFR Part 11 compliance also required. So in that software already it is there. You can, as per the pharma requirement, you can give the privileges to your users, your managers, and they can only do that much. They can't do much more changes in the results. Similarly, for the maintenance also, in maintenance, automatically they give the warning how many samples it is done, and now that reactor comes to the end for the exhausted. So maintenance program also possible to do it there. Now, most of the times, what happen? Halogenated compounds customer want to analyze. To do that, any halogenated sample is there, and mostly what happen? Fluorine is very dangerous chemicals. It is killed your reactor. So what happened? Due to that fluorine, there is a chances you could not get the repeatable results. So there is a chances of if high fluorine is there in your sample, it will the damage the reactor. And if you want that type of that sample, so uh, that fluorine absorber thermo has prepared. So that part number is also available. You can use that part number and you can order it. Yes, but only remember that in due to that fluorine absorber, you can't analyze sulfur. You can analyze only carbon, hydrogen, and nitrogen because that fluorine is absorbed. Not only fluorine, same time it can absorb the sulfur also, and there is a chances we are not getting proper sulfur. And this is required most of the pharma customer for you can ask the customer if you have any fluorine or not in your sample. If it is there fluorine percentage is high, then please do not directly aspirate, otherwise your reactor will spoil immediately. Now I already explained that suppose in sample analysis, if you see that the application in food industry, or you can see that the soil industry or oil industries in coal and coke also. See, there is a different types of sample will be there, but the sample preparation is very important. Homogenization sample is very required because we have to take only 2 to 3 milligram of sample. So first you can due to the homogenization with the boil mill or any piston is there, you can use that and crush the sample. You can convert it into the fine powders. Sample should not be required any moisture. Yes, maybe the chances sample may be hygroscopic. So before you can dry it also at oven at 105, and then you can take a very small amounts of sample weight in a tin container 2 to 3 milligram with the help of the microbalance. Do not take the weight on analytical balance. If you are taking the weight on analytical balance, means that accuracy is not there and we are not getting a proper uh, results in your analysis. Then you can put your samples in that auto sampler tray. Okay, for that solid samples, you can directly take the weight in soft tin container. But if any liquid sample is there, so you can use that the hard tin container, and hard tin container also sealing device will also come with the instrument. So use of that. Suppose any liquid sample is there, and after that you can analyze through that CHNS configuration, and you can uh, find out the element concentration. In petrochemistry, coal sample, you can find it and then you can take that sample. Yes, in petroleum industries, coal and coke, most of times they are interested in heat value, that is gross heat value and net heat value, because on that basis, that cost of that coal is depends. So thermo eager smart software, it is capable, it is not required to only do the only CHNS, but that software through you can also calculate that gross heat value as well as net heat value. In that software, that one formula is there, you can put it how much percentage of carbon, hydrogen, oxygen and sulfur, and then software automatically calculate the gross heat value and net heat value. So no need required to keep another calorific value instrument. So if you see that the CHNSO determination, same times you can calculate the gross heat value as well as net heat value. So in heat value calculation, there is a table. You can use that the carbon, hydrogen, oxygen, and sulfur. and then automatically you can calculate the heat value of that compound. Now, suppose same times you can analyze of oil sample by ASTM methods also. So ASTM 5289, there is already that is a standard test method. That is the instrumental determination of CHN in petroleum product. That is by the ASTM 5291. In that 5291, already it is ASTM has mentioned that they can use the Carla Erba instruments. That before that thermoplasma or thermo instrument, uh, this machine or this instrument in the representative of the Carla Erba. So already in if you see that Lico, Perkinen and Carlo Erba is there. So Carlo Erba is nothing but that today is a thermofission instrument. So that oil sample also you can easily analyze carbon, hydrogen and nitrogen through that our instrument. That is a flash mark. So in thermo, you can find out the nitrogen also in lubricant oil through that 5291 instrument method. Carbon, hydrogen, nitrogen, as well as sulfur also, no doubt about that. And ASTM, it is accepted that through the thermofission instrument, it is possible to analyze that nitrogen, carbon, hydrogen, sulfur. If you see that the repeatability and reproducibility also, the RSG is less than 1%. Similarly, in lubricant oil also, you can find out the nitrogen only because most of the times they are very interested in nitrogen analysis, and up to low ppm level also you can analyze of that. Previously also we have to discuss about that for the trace sulfur analysis, Fpd detector. So Fpd detector is outside that the instruments. See here it is, that is the called Fpd detector. This is our flash mart and it is outside that instrument. That is we call that the external detector. Internal detector is the TCD detector and external detector is the Fpd detector. So through that CHNS reactor, then it instead of it is going to the TCD detector, that wire is going to the Fpd detector. Here it is a H2O trap is also there. GC column, it is very separate, not like a CHNS column. It is different. Here it is a Fpd detector, and you can measure the sulfur as a SO2. Only single peak you can see that. And where we can find out of sulfur in diesel, biodiesel, gasoline, graphite samples, coke, catalyst also. So for the trace level analysis of sulfur, use the FPD, flame photometric detector. If you see a reference liquid solution, here it is 5 times you have to run that 100 ppm, and we can see that reference liquid solution up to 5 ppm we can easily in liquid. Mostly we can liquid you can easily go up to 5 ppm, no doubt. But for the solid, yes, it is slightly go up to the higher concentration level, means up to the 25 ppm up to you can easily detect. Now in agronomy, that is in soil samples, the same like coal sample, homogeneity is very important. That homogeneous sample is required, dried it, pass through that mesh sieve size of 2 mm, then again crush it by a motor or ball mill, and then a fine powder you can use for the analysis purpose. There is a one more thing is there inside that the you can analyze that TOC also, total organic carbon. See here it is we have to find out carbon of total carbon, means organic as well as inorganic. But if you require only organic carbon, then there is a very not we can say that a very sophisticated instrument is already available in market for TOC. But Thermo has developed that one technique. So where you can find out the organic analysis, organic carbon in soil samples. With that help, there is a one hot plate is there. We can use the silver container. Um, in that we can take directly acid sample, means fine powder, and we have to add that acid. Which acid we are using? Hydrochloric acid. That is 1 as 1 hydrochloric acid, 5 to 6 drops we are added. And we are kept in here on hot plate. So what happened? Whatever inorganic carbon is there, it is react with HCl, means that is converted into carbon dioxide, and it is evolved. So whatever it is remaining, that is that only organic carbon. So if you want that, first we have to analyze acid sample, that is a mixture of organic and inorganic carbon. And here we can analyze only organic carbon. And that basis you can give the results. But this is a typical method. It is not, we can't say that it is a sophisticated instrument like TOC. It is normal chemistry, we can apply it here. Now the same things in other food samples also. First we can dry it, mix it properly, and then fine powder we can use for the sample analysis. Remember friends, it is very important. Sample is required homogeneous. If your sample is not homogeneous properly, you can't get proper results. Again, it is moisture will be there. You can tell it before that the instrument, that substance or that material is hygroscopic. There is a chances when you take the sample weight, it is absorbed some any moisture or anything. So we can weight only up to a very small milligram, 2 to 3 milligram. Why we are taken only very small amount of weight? Because that combustion is required very fast, and it is happening only for 5 seconds. If I take much more sample weights, so combustion is required also much more time, and there is a chances not completely combustize properly or not. And for that reason, we have taken only a optimized weight. That is the 2 to 3 or maximum 4 milligram, not more than that. In oxygen analysis, we have taken only 1 milligram sample weight. So if in your sample organic content is very high, then sample weight is very less. If in your sample organic content is less, then we have to slightly increase the weight. So here it is a comparison. If you see that nitrogen and carbon single reactor and nitrogen and carbon double reactor. Thermo already provided the NC soil configuration with a double reactor. And they have to develop one method in factory by using the single reactor also. So in here single reactor, you can see that nitrogen by single reactor is 0.272, and if you are using the double reactor, it is a 275. Now if you see here nitrogen by using single reactor, that is a 272, and nitrogen and carbon by using the double reactor, that is the 275. Similarly, in single reactor, other one is there, that is the loamy soil. In single reactor, 0.271. Similarly, if you see that the carbon 0.2754, again double reactor is 2734. So very correctly you can do it by single reactor as well as double reactor. No doubt, single reactor the chemical is different, and double reactor that it is very different. So these are the things we can compare with each other. Sulfur also, you can see that sulfur also you can measurable 0.0426%, and here in 0.4028. These are the NCS, and this is only sulfur by single reactor. Yes, in NC soil, yes, you can take the sample weight slightly higher, because in soil samples, most of the things, uh, inorganic material are much more. So ash content will accumulate it much more. Uh, so organic content is less, so you can take the slightly higher sample weight. But remember that when you take the higher sample weight, like soil sample, so ash will also very high. So maintenance part, it is required frequently. So you can do it maintenance part on regular basis. You can clean the reactor, or you can clean the crucible that inside that reactor. Uh, there is ash is accumulated. So there is a possibility you can clean it, means after 30-40 samples you can clean it and then again do it. Otherwise that peak pattern will not come properly. Even RT also shaped it. So there is a chances it will be happen. So these are the things we have to do through the CHNS flash mart. If anyone have any doubt or questions, uh, they can please ask.
Thank you, sir. Let us begin with today's question and answer round. The first question is by Dr. Daminder Singh. He want to ask that how can we find the values of CHNS manually? Can we have the manual calculations for CHNS? Hello,
Uh,
sir. Am I audible? Yeah.
yes, sir. Yes, audible. Yes, actually, what happened here is the same thing. We have to apply like other elemental analysis technique. First,
Yeah.
we draw the linearity with the known concentration of that standards. So we have to use the BBOT or acetylamide, that type of standards that we have to supply with the instruments. Means fixed amount it is there. Means in BBOT carbon is 72%, nitrogen is a 5%, hydrogen is a 7%, sulfur is a 10%. It is like that. So we are using this type of standards, that organic material, to draw the linearity, and on that basis we have to analyze that our samples. That is really good question, I missed that. Remember that, friends, when you do the analysis, see what happened, we don't know how much percent of carbon is present in my sample, how much percent of nitrogen is present in my sample. But remember that this is the comparison technique, so always use the standard uh, to the nearest your values. We can't say the exact value comparison, but suppose in your sample carbon is 45% and you are using only a 10 to 20% of carbon of standard using for the linearity, then there is a chances your result will not match properly. So instead of there, you can use that type of standard. It will be higher than in that you in your sample component. So
Okay. Thank you.
always use that type of standard component. It may be slightly higher, not much more higher. Also means similarly, like in your standard carbon is 90%, and you want to analyze of 5 to 6% of carbon only as compared with the 90%. So in that type, you can use that 30% or 40% of carbon standard.
Okay. Thank you, sir. So the another interesting question is by Dr. Akhil Mohan. He's asking that if elements are present in ppm, how can we analyze them in ppm using CHNS instrument?
Yes, it is really interesting.
Yeah.
Actually, sir, the limitation of CHNS is up to 0.01% you can analyze, because that TCD detector also you can't measurable. Means if you see that nitrogen in your blank will be, means carry over, it will become to the helium or oxygen, so it will be interfere in your results. So limit up to the 100 ppm you can easily detect. Uh, but practically we can say that yes, about 200 ppm you can measure it. But below that, it is not possible that CHNS. And again, ICP OES and ICP-MS, it is also not possible the carbon and hydrogen. Then we can think about that other technique. But right now, I am also not aware which technique you can use for nitrogen or carbon or hydrogen. Yes, in sulfur by ICP OES, it is possible to analyze, but up to some extent, up to 50 ppm only.
Okay, thank you, sir. So he has also asked that during CHNS analysis, if sulfur content is not there, what will be the conclusion?
Conclusion means you can't, if it is in sample, it is not there, so there is no issue. Means, and again, remember that it is not most of that time customer is thinking CHNS, so 100 that average or total should become 100%. It is not like that. It is depend on your sample formulas. What is there? It is 100% is there, then instrument is showing the 100%. Otherwise, what happened? Most of times, customers is given some oxides or anything, so it is not possible to match the 100%. Again, one more thing: in your sample, suppose sulfur is very high, so you can use one more chemical. That name is vanadium pentoxide, because sulfur is very tricky to easily oxidize at 950 degrees centigrade. For that reason, we have to add the vanadium pentoxide also, because much more oxygen will generate during the combustion and it will be react with sulfur easily. In your sample, sulfur is not there, so there is no issue. So there is nothing absolute issue to do the analysis.
Okay. Thank you, sir. So the another question is by Farah Ansari. He is saying that, sir, asphalting are complex insoluble precipitates extracted from crude oil. So what precautions we need to take during its elemental analysis in order to maintain the homogeneity?
Yes, that is very interesting. If you see that any precipitate or anything is there, first you convert into the fine powders. If it is fine powder is there, then and then only you can analyze. Means you can get the repeatability in your results.
Hmm.
Otherwise, there is a chances sometimes carbon will high or sometimes nitrogen will high accordingly. Means fine powder and homogeneous sample it is required, because we have to take sample with very nominal, means only 2 to 3 milligram.
Okay. Thank you, sir. So the next question is by Manikandan. He's asking that is it possible to sediment nitrogen value zero or negative?
Uh, See, zero will become, yes, I can accept that. Negative, why it is come negative? Remember, not only CHNS, in any analytical technique, negative value when it's come, uh, because it is a comparison technique. See, when you run your blank sample in ICP OES or ICP-MS or even in LCMS or GCMS or GC, your blank value is suppose X, means we can say that suppose 200 in area, or ICP OES, that is 200 counts per second, and you are in your sample unknown sample you are run it and you are getting that value 150, means it is less than that blank, and that's why it is showing a negative value. So negative value is nothing, but don't worry about that. Only you can worry about your blank intensity or blank area. If it is blank area is very less, then in your sample it is very less. You can detect. So it is possible. Sometimes it will become to zero also, or zero or negative.
Okay. Thank you, sir. So the next question is from the IIT Bombay user. He's saying that do this instrument have exhaust or chimney along with scrubbers? As he's saying that SO2 exposure is injurious to health in the closed environment.
Yes, actually, what
Yeah.
happened? See, in here we have take the sample weight only 2 to 3 milligram, not more than that. So that gases is generated comparatively. If you are do the any reaction or anything, it is very nominal. Means yes, it is no doubt there is a sulfur dioxide is always dangerous, uh, but it is very nominal gas will generated. If you can use it also, very even smell will also not come. So I think it is not required much more. Yes, but exhaust is there. It is good for the any instruments.
Okay. Thank you, sir. So the next question is from the Kokan. He's saying that in case of pitch, that is bottom end product from the crude oil, it will stick to the crucible. So how can we clean after use?
Uh, can you repeat that question? I could
Yeah,
not
in
understand.
case of,
Miss.
yeah, he's saying that in case of pitch, that is bottom end product from the crude oil. So it will stick to the
Okay.
crucible. So how we can clean it after the use?
Means it is in tin container or any round bottom flask or
He is
anything. Means
saying
there.
sticking to the crucible. So
Okay, in tin okay
in
tin
crucible,
crucible.
yeah.
Because what happened in tin crucible means we have to use only one time. Means it is it is completely burn it, so it is not
Yes.
required. Only the reactor part. See what happened. Reactor quartz tube. We have to not reuse again and again. We have to throw it. Means once we can just filled it, use up to 200 samples, and after that again we have to use another reactor. Yes, but suppose any ash will be there, you can clean it. Means you can rugged it properly. Only take care of that. That cords will not broken.
Right. So the another interesting question is from Dr. Mayuri Gandhi. She's asking that sulfur and diesel samples and carbon and steel can be done with this same instrument.
Yes, it's very interesting. Yes, diesel sample, liquid sample, you can use it by the Hartin container and all that. Yes, but steel sample and all, it is not possible right now because I am also not do that because it is require high temperature for that combustion purpose. Um so most of the times people are asking that in steel sample carbon contain or nitrogen contain. Mm, so so there is the chances the authenticity will come properly or not because without complete combustion you can't get that proper results.
And even she want to know that is heat value is a calorific value.
Yes, heat value you can find out in organic sample. There is the already formula is there. You can just put it how much percent of carbon, hydrogen, oxygen, and sulfur. On that basis, you can find out.
Yeah, but the heat value and calorific value are same, right?
Yes, it is the same. There is no any changes.
Okay, okay. Yeah. So the next question is from Pragya Bedwal. She want to know that can we analyze the gaseous fuels as well from this instrument?
Uh, right now, madam, I am not using that, but only we have to use solid and liquid sample.
Yeah.
Uh, Maybe the possibility we will ask the factory. It is a really nice question. Whatever question is there like that, we can ask the factory. Any accessories is there or not?
Right. Okay. So the next question is that can we analyze the samples having water content in it?
Yes, you can analyze that because we have to analyze plain water also by the
Okay.
CHNS, and that hydrogen value is exactly match.
Okay. Okay. Yeah. So the last question. Can we determine the TOC from the organic elemental analyzer?
TOC, total organic
The
carbon.
total
Yes, you
organic
can.
carbon, right?
Yes, you can analyze. We have that accessories, and but only I'm just saying that means you can't remember, means you can remember that, don't forget about that. It is not a already in market. TOC analyzer is there. You can't compare the results of this TOC and that TOC. Means that this is a sophisticated instrument for only for TOC purpose. And here it is thermo TOC. It is mainly using for the inorganic material, maybe inorganic carbon in the form of carbon dioxide. You can release it with only adding the acids on that basis. So you can use this only that purpose.
Okay. Okay, sir. So I think all the questions are done. Yeah, so we are really grateful, sir, for answering all the questions. So on behalf of SEF CRNTS, I would like to thank Mr. Chandrakant Pawar for interesting talk on CHNSO elemental analyzer and its applications. I would like to thank our head, Professor Suparna Mukherjee, and our SEF CRNTS team members for their continued support in this webinar series. And last but not the least, I thank all the participants for attending this webinar and making this event successful. A link for the feedback form is shared in the question and answer section, so please do fill the form. Your valuable inputs are important to us. Thank you. Sir, and yeah, we also got one more question that will you from the IITB guest that will it be possible to you to arrange the ICP webinar?
Uh, Actually, madam, I asked my seniors, and definitely I will arrange. I'm very happy
Yeah.
to give you the, because I don't know which instrument you have, but yes, see, technique is technique. Technique is the same, and I can give your answers or whatever your doubts for sample preparation or analysis or any other techniques or method validation part, or how you can troubleshoot any matrices. Yes, I definitely really happy to
Yeah.
give the solutions to you.
Okay, sure, sir. Yeah. Thank you so much, sir. And thank you all of the participants. Thank you.
Thank you, madam.
everybody. Thank you.
Thank you, everyone.